A very warm welcome to all of you. I'm audible, right at the end. Thanks for introducing me so well, and the topic also, going atomic with containers in your infrastructure. Everybody's heard about Dockers, right? Let's have a raise of hand. Docker. Yeah. Run C. No, okay. That gives me a good idea. The idea of this presentation for me is, the takeaway for you should be, you should know what is containers. And if you're seriously looking at a strategy around containers for your organization, what are the gotchas that you got to watch out for? We are in a similar time where a few years back, we had the cloud coming around. Sometime later, we had OpenStack. And there is a lot of confusion around how to take these technologies, how to consume them, how to make the best use of them, right? So look at these two things as a takeaway from this session. I request you to hold on to your questions till the end of this session. We are running pretty tight show here. I'm available after the session for question and answers with you one-on-one. So let's get started. We all are pretty much on the same page, I'm sure, when I say 80% of our IT budgets today are going in keeping the lights on. Do I strike a chord here? Do we know what it takes to run operations to ensure your infrastructure is stable, secure, and when a workload has to be reprovisioned, it can be done in quick time? Those are the processes and environment in which the operations team ensures our applications are available to our users. That's somewhat around the current state: manual processes, inconsistent environments, right? A long list, you will all identify with that. Where do we want to go? What is business telling us when a company like Uber has taken the ground underneath the feet of our taxi operators sitting out of North America? We all realize how time can change for someone, for an industry, right? It's not very far. Once we identify that, so any technology that's coming up requires our attention to at least evaluate it in terms of, is this going to be useful for me or not? And then decide on, you want to pass it, you want to invest in it. That's where containers is here today. So business is saying applications need to be agile. Feature enhancements should come as soon as they can. Developers need to bring in more and more value through their applications, even though it requires a complete application stack to be provisioned in quick time and taken to the market. Now look at this from the operations side once again. It feels as if they are under attack, right? New applications, new environments, right? Each one of them a different application stack altogether, right? From storage to database to application server to the programming development environment, right? Realize where they are. Nobody is wrong here. When we say DevOps, an effort has to be taken to start the operations team talking to your developers. There is a reason to it. We've seen that the industry, these two organizations don't see face-to-face very well because of the nature of their environment. Applications, developers have to go very fast, very agile. Operations has to be very, very stable, under control, right? So where does that take us? So initial few slides, I'm just creating the context. So what is Red Hat's vision here? As you have these different ways of deploying infrastructure, be it physical, virtual, in your private cloud or the public cloud, you do not want your stack to be different according to where you're going to deploy your applications, right? There has to be a consistency. So Red Hat brings in the concept of the open hybrid cloud. Open refers to open source, because open source fundamentally allows freedom of being able to choose your components. And hybrid, to say that there is a very clear plan and ability to work from the public cloud to the private cloud and back, right? You should be able to go from private to public, public to private. Otherwise, it's another lock-in. And lock-ins are not good, right? Are lock-ins good? Do we have great bargaining power when we have a lock-in? No. So there are a number of benefits that containers deliver. Some of them are already there in your mind. And we went to our customers and asked them, how important are the following benefits of containers to your organization? And this was the feedback. They looked at security that containerization would deliver for their application as one of the highest ranking expectations from containers. The next was the increase in server consolidation ratios, greater application and mobility, as well as portability, right? So while containers as a technology is going to have very clear and direct benefits to the development organization and the operations organization, it affects all of us, be it users, be it the business side. It's going to affect all of us because they interact with us, we interact with them on a daily basis. Another survey of organizations that were playing with containers came back saying that 64% of them are already using or evaluating containers for future use, and around 67% plan to put them in production within the next 2 years. Very profound numbers, right? Are so many people already so clear about how they are going to use containers? Are there already so many ISVs who have made their application available in container format to be deployed at our end? Let's see how. Let's see how this goes. So I started with the question, if we've heard of Docker. So Docker, what is Docker? It's a company. It's an image format, a container image format. And it's also a set of tools that are used to manage containers, right? Are they able to do everything required around a container infrastructure today? No, that's the point of this slide. It's trying to be funny here, saying that Docker needs help, it's the large ship in between, and there are providers and the ecosystem around them who should come across with the ability to be able to scale containers very well, the ability to improve the security in containers very well. Those are the things that needs to be added and make it enterprise ready. The next one here, now we also want to know what are the challenges that could come up, right? I start walking on a path. It's not ideal that I have to walk back, right? I'm losing my competitive advantage. So that's what I will focus on in the next few slides. Now I hope I have clarified what is Docker. I talked about another thing called runc. I'll come to that. What are containers? We all understand virtualization very well. And in case of an hypervisor, we install an entire operating system, which is a virtual machine, in which goes my application. Alternatively, historically what we've done is put the application directly on the bare metal OS. In case of a container, what am I doing different? The application, when it comes to a container, it needs the libraries that it's dependent on within the container. The rest of the functionality that an operating system does can be common to all applications, all containers. Is it very simple and easy to differentiate from virtualization? Because that's what happens sometimes when I'm talking to people. Because we know virtualization so well, we try and equate it to virtualization somehow. Big difference. If you heard Ranga in the morning, he talked about how a server, a particular server, if it can run 4 virtual machines, it could run 40 or 100 containers on that same box. What does that tell us? Is it exciting or not? Right? So all a container needs to run an application is the application and the dependent libraries that that application requires. And yes, it is a bit of a complex technology where you need to be able to run that entire application within the container. You need to do a few rounds of making this software available, making that software available within the container, because it is not going to be able to access stuff outside. But once you get there, then what it delivers is fantastic. Now, I'm ready to move on. We went to our customers who were already looking at containers very seriously and asked them about what are your top container challenges. And they came back with, once again, security, variable performance depending on where I'm going to put the container. These are questions. Integrating with existing tools and processes. The developers are used to a certain IDE, a certain environment, the way it behaves. So are the operations guys, right? They're very comfortable with the tools that they use today. How is it going to change when it comes to containers? Does it look a bit similar to the way we talked about when we talked about cloud? Security. What will happen to my data? Those sort of things. But we are not yet saying you need to have all your containers on the cloud, right? But still there are questions around security. So let's see how Red Hat moves on and addresses this. So to take this case forward, I talk about an application, and I can easily say the most loved application for the developers at least, and it's called Hello World. Very small one. All I need to say is hello world in my application. So I do it in C++, I do it in Node.js, I do it in PHP, Python, and this is what it takes. But what I'm getting to is, so this is the contents of your container. You need to be worried about what does this container contain in terms of the application stack. Is it updated, right? You see these yellow triangles. I'm sorry, the font inside the triangle is not readable. It's talking about the vulnerabilities, medium to severe vulnerabilities that were found in about 60% of images out of about 1,000 images from Docker Hub. Survey was done by Banyan Ops. So what does that tell us? And what is this? Let me go deeper. I'm sorry. Node.js, 5 vulnerabilities were identified, and this is the period of the release of RHEL 7, around 12 to 16 months of RHEL 7. JRE had around 66 bugs and vulnerabilities identified over the period. Of course, when you're using an OS and you're patching it, this is all covered. You need not worry about it. The other operating system environments are also taken care of the same way. But what I'm trying to say here is, with containers, how should we take care of this infrastructure? These are the areas you want to watch out for. These are the areas you want to make sure they are addressed. Another example is Bash 4, glibc 6 or 5. All the components inside, over a period, come up with issues that are found by people, right, over a period of time. Now with containers, the concept is you're not patching a container. You change the container image. You run stateless apps on top of a container, and you have more than one container catering to the load. Take one container off, give it the updated image. Take the next off, give it the updated image. So your availability is constantly there. You're not taking your entire infrastructure down at any point of time, but you're not patching containers, you're giving it an updated image. So it's important to know what's inside the container. So the ops guys understand this, and they're worried about it. And we all understand why now, right? Because they have to make sure the environment stays secure, does not get hacked into, continues to work as it is doing when they have deployed, be it UAT, be it development, or be it in production. So that's about the number of vulnerabilities that were found out. 36% of the images in Docker Hub had high priority security vulnerabilities. That's another point. And last year typically had quite a few famous ones, right? Shell shock, Heartbleed, and so on. Which is only coming across with the fact that in open source, you get to know what's happening. The vendor can't shield that there is something wrong. Vendor has to come back with a fix. Think about it in the proprietary world. You never have these insights, right? Until the vendor says, here's a patch. And then you say, yes, okay, this patch has to be applied. But you don't know since when you were vulnerable. So I have no qualms putting up the previous slide in front of you saying that so many things happened over a period. This is the way software works. People develop and people make mistakes, and those are there in the form of bugs and vulnerabilities, and they are patched over time, right? So what does Red Hat do in this environment? Our aim is to ensure that the adoption of containers should not have such cobwebs, if I can call it that, right? You should be at peace when you're saying you should be assured of, okay, my container, right? I know what it contains, so you are expecting your ISV to deliver an application that he has developed and says, yes, this is fine. You have Red Hat saying that this container image is certified, right? Because it's a component that will run on top of my container platform. Also at the bottom, the container platform is something that Red Hat says, we have certified, we keep it updated for you. So just like we had the value with Red Hat Enterprise Linux, that's why you use Red Hat Enterprise Linux, right? We continue to support Enterprise Linux, for example, for 10 years plus 3 years. What does that translate for a business? That even though my hardware keeps changing, the updates to Red Hat Enterprise Linux ensure the latest drivers will work with this latest hardware and deliver what I'm expecting out of these new investments, with the consciousness that Red Hat has taken care of the certification process. So we are making a container development kit available for our ISV partners so that they can port their application to containers. We are offering a certification as a service to our ISV partners. They work with us, and at the end state is Red Hat says, and the ISV says, this container is certified to run on Red Hat Enterprise Linux or Red Hat Container Platform. We publish this certification catalog so that customers like you are able to go to our website and say download, try and boot it up in your environment and use that application. And that's our certified container registry. So you want to be able to look up, right? Search, I need an ERP. Do we have a container? So the same way that you use containers today, you look for images, but you do it in a marketplace where you have certified stuff available from your vendors. So to summarize, Red Hat Container Solutions want to deliver that you have a modern application development environment. We want to ensure that your consistency across development to UAT to production does not suffer. You should be able to smoothly transition across these environments. Right? You don't want the operation team or the UAT team coming back to a developer saying that we are finding bugs in this that should not have been there. And that guy comes back, the developer says, this didn't happen on my laptop. It works fine on my laptop. So what if it's his laptop? His laptop can run a container that can be just put into UAT. That is the vision, right? Because these are really light. Flexibility and ownership. Flexibility in terms of being able to run containers across platform. So I mentioned before, right? Or I didn't. The open container format. Docker donated its container format as an open source format, and CoreOS guys who had a different specification for containers called runc are now helping the open container format ensure that Docker image is able to run with the specifications that runC also talks about. So the aim is to be able to deliver one container format, which is the pain in virtualization today. Can you take a virtual machine from X hypervisor to hypervisor Y? No. Whose loss is it? The customers. You're struggling to have a single pane of glass across these infrastructures, right? So with containers, Red Hat is investing in standards. So right from when we started with SE Linux on the RHEL side, how many of you have heard of SE Linux? Excellent. One of the most underrated tools and something that has no counterpart in any other operating system environment. With respect to process level security, on the box, as far as going to giving you details of audit also with the multi-level security policies. So we are ensuring that isolation of containers, just like in Red Hat virtualization, a VM is isolated with SE Linux by default. SE Linux is in enforcing mode on a RHEV hypervisor. Same way, we are investing in ensuring containers are working in a contained environment using SE Linux. A common container format I talked about some time back. Orchestration with Kubernetes. Now what is this? It's very important that we realize that traditional apps are not just being ported to containers. Large monolithic apps don't lend themselves very well to containers, right? So we should all do a homework on this, because application development, application stacks is a very large topic of discussion. All I want to share here is, you heard about microservices earlier, where a monolithic app is now broken down into pieces. Why? Now think about it. Your app had an issue when it was a big monolithic app. How did you troubleshoot it? You had to get into different areas trying to figure out what is happening where. In the new way, if the application developers have put all the application components as microservices, you will be easily able to identify which microservice is under stress. And with containers, you should be able to scale only that piece of the microservice. Your job is done. You don't have to worry about the entire application. Now again, this is the promise. ISVs have to deliver on this. There are many ISVs that if you go to openshift.redhat.com, thousands of applications already running there, right? People are running their SaaS services out of openshift.redhat.com. So with OpenShift version 3, Red Hat took this software component called Kubernetes, which was open sourced by Google. Once Docker started getting momentum in the market, Google came out in the open and said, guys, we've been doing this for more than 6 years now. Inside of Google, we don't run virtual machines, we only run containers. And we manage and orchestrate these containers using Kubernetes. Thanks to Google, Red Hat took Kubernetes, Red Hat took the Docker format, and OpenShift version 3 was developed, moving from OpenShift version 2. Version 2 already used Linux containers, LXC, already used SE Linux. But with Kubernetes and a Docker format, it made it so much more flexible and consumable by enterprises in terms of 2 large open source software projects coming out in the open and immediately delivering a very high level of code, rather than Red Hat having to develop all on their own, just like we do with our other products, right? Open source development model is something we all need to be very clear about before we start consuming enterprise open source. There's free open source software and there is enterprise open source software. So when I say a stock exchange or a Cleartrip or a bank is running open source software, they are running enterprise open source software. They are usually not running the free stuff, okay? And finally, the container registry discovery, so that you are able to search and get the container, the application of your choice, and deploy it in your infrastructure. So that's a big drive, and it's very valuable for making containers successful in the marketplace. So coming back to the way we started, we have multiple ways in which we deploy our infrastructure: physical, virtual, private cloud, public cloud. Red Hat has ensured that our Red Hat Enterprise Linux server can run containers. Red Hat Enterprise Linux Atomic platform can also run those same containers, but it is somewhat of what a hypervisor is to a virtual machine. Atomic platform is for containers. It is built to run containers. The next is Red Hat OpenStack platform. Red Hat OpenStack platform should be able to run containers just like it runs virtual machines. OpenShift, I already talked about. It consumes Docker as the image format. It is orchestrated using Kubernetes. And finally, Red Hat Cloud Suite. Now, while these are just names of products, I'll just show you how they bring about the value. Now, you're not going to have a completely containerized environment. So we have traditional applications sitting on physical and virtual, and you have the new applications that are created with the microservices architecture. They're sitting inside of containers. These both have to be able to manage, right? You should be able to manage both environments. Some ISVs may not come out with container formats very soon. So you need to be able to manage both. So Red Hat has three offerings here largely now I'll talk about is Red Hat Atomic Enterprise Platform. That is a foundation to run containers. Red Hat Enterprise 3 version OpenShift and Red Hat Cloud Suite. So like I said before, Atomic platform is my platform to run containers. It also has the orchestration tool called Kubernetes available to manage applications that are multi-container. Now realize what I am talking here, and we are already there because there are certain ISVs who are already working with us very closely. You have one application which has multiple containers, and I talked about a situation where the application is under stress. One of the microservices has to be scaled out. Who's going to do this? That's where Kubernetes comes in. Kubernetes is the orchestration tool to manage multi-container applications. That is built into OpenShift, and that is built into the Atomic platform also. Just a step above, you want your developers to be able to consume this platform without worrying about setting it up, without worrying about putting containers on top, putting their application stack inside it. So you have a PaaS platform from Red Hat that consumes containers, that at a browser console, on click, allows your developers to work with their IDE, upload their code, and run their code inside of a container. A complete PaaS platform. This builds on top of containers. So if I can represent it in a different form, Atomic platform has value up to this point: container orchestration and management. While OpenShift continues to give you language runtimes, middlewares, databases, developer tools on top of this container platform. Is the distinction clear? And finally, the Cloud Suite. Now, the host OS, for example, has to be updated. It has to be patched. So you have the Red Hat Satellite as a systems management layer, which many of the customers are using today with Red Hat Enterprise Linux. Additionally, so you have virtual machines, you have cloud instances. This is the infrastructure as a service layer. This is the platform as a service layer. Here you have the hybrid management layer. Red Hat's product is called CloudForms. As of today, CloudForms can hook into an existing VMware infrastructure, an existing Hyper-V infrastructure, Red Hat Enterprise virtualization infrastructure, an OpenStack infrastructure, and if required, talk to AWS and deploy your workloads that you are today deploying on any of these private cloud infrastructures. CloudForms does this today. So you have to see this closely. At the bare minimum, you have the atomic enterprise platform. Over and above that, if you need more agility and flexibility out of the box, you could go in for Red Hat OpenShift Enterprise. And when you want a full-scale management platform with traditional environment and containers together, you can go in for the Red Hat Cloud Suite. On top of which, your middleware and mobility services would come. And here you have the certified application ecosystem, the ISV ecosystem, the marketplace, if I can call it today, right? We all identify with the marketplace today. So, in summary, once again, our various choice of the way we deploy our infrastructure, the choice of your host platforms, right from Enterprise Linux to Enterprise Atomic Host to OpenShift to Cloud Suite, to be able to provide flexibility and scale across traditional applications to containerized applications, choice of content in terms of what application stack would sit inside these environments. So here you have Perl, PHP, Python, and so on. This is the vision towards which a customer should be able to walk today. This is Red Hat's approach to containers and the work we are doing around it. This is what I wanted to present to you. Just one or two more slides. Okay. Our perspective, the security aspect. We need to keep in mind that containers contain some software stack that has to be secure. This is a snapshot of CloudForms when it can monitor containers. This should be out by December. It's talking about the container repositories that are available to you. It's talking about utilization of containers that you have deployed. It's talking about memory, storage, and network aspects that are being consumed by your infrastructure. This is just a screenshot. This product will be enhanced to work with containers by the end of this year. That's what we are talking about. So finally, the takeaway that we should all have from this presentation is Red Hat is in the business of ensuring that you have a trusted environment to run your containers. You have the promised portability once you move to containers, right? Whatever your container deployment platform, your container should just go and you just have to boot it, because we are delivering one container format. And finally, an integrated experience where container applications will need to work with the traditional applications also. So there the integration, etc. will have to be able to happen. The APIs have to be able to be accessible for the other applications as well. So that's all in all what I had to deliver. Thank you very much for being such a patient audience. I hope I have been able to deliver to you minimum 2 takeaways that I talked about earlier, right? If you find containers to be attractive, how do you want to go about it? And what are the gotchas in terms of a secure platform, thoughts around what is inside the container, etc. Thank you very much.